And finally, the last sample problem is sample problem number 2. At a particular temperature, K is equal to 3.75. If all 4 gases had initial concentrations of 0.800, calculate their equilibrium concentrations. Okay, let's go ahead and set it up. I, C, and E. So 0.800 molar initial, 0.800 molar, 0.800 molar, and 0.800 molar. Now, because we have non-zero amounts of all reactants and products, we don't know which way we're going to shift. And so this is a twist on things, and now we have to solve for Q. So Q is going to tell us which way we're going to shift. So this is going to be equal to concentration of SO3 initial times the concentration of NO initial divided by concentration of SO2 initial times the concentration of NO2 initial. And that's just going to be equal to 1, everybody. 1.00, which is going to be less than K. And because Q is less than K, that means we are going to shift to the right. Therefore, the sign that goes here is going to be minus X. This is minus X. This is plus X. This is plus X. And so we're going to get 0.800 minus X. 0.800 minus X. This is going to be 0.800 plus X. This is going to be 0.800 plus X, everybody. So K is equal to 3.75, and that's equal to 0.800 plus X squared divided by 0.800 minus X squared. So we can use what we call a perfect squares to solve for this. And so the square root of both sides, everybody, is what we're going to do next. And when we go ahead and do that, we're going to get 1.93 is equal to 0.800 plus X divided by 0.800 minus X. When all is said and done, X is going to be equal to 0.25 molar. And all we do next is simply plug it back into all of the expressions at equilibrium. So the concentration of SO3 at equilibrium is equal to the concentration of NO at equilibrium, and that's going to be 0.800 plus 0.25. I'll let you guys do the sum. That's going to be 1.050 molar, and the concentration of SO2 at equilibrium is equal to the concentration of NO2 at equilibrium, and that's going to be equal to 0.800 minus 0.25, everybody. And we're going to get 0.55 molar for these guys. Okay, so that, everybody, is use of the ICE table when we have all 4 initial values present. Once again, you got to find which way it's going to shift, and you do that by evaluating Q. Alright, so that's our lecture from General Chemistry on the principles of chemical equilibria. And I want to thank you for your time, and I'll see you next time on Educator.com.